Welcome to NYNJPA Weather, your weather source for the Northern Mid-Atlantic. I'm meteorologist Stephen DiMartino, and boy do we have a lot to talk about, and we only have 10 minutes to do it, so let's get to it. Here's this morning's surface map, and you can see that our big coastal storm for New England is moving into the Canadian Maritimes. High pressure is generally in control. There's a few clippers that are passing to the south of the northern Atlantic, but will not produce much in the way of precipitation. A few scattered snow flurries are possible for southern Pennsylvania and southern New Jersey, but no accumulation is expected, and for the most part, no one will experience much of anything. High pressure will be in control through at least Christmas Day. And then things get very interesting, and there's a lot of hype out there about a major storm, but today we're going to show what could go right and what could go wrong. Now, the potential major storm is out in the Pacific right now. It's off the California coast. That's one piece. Another piece is to the west of British Columbia, and we have another one over the Arctic. So let's dive in and really look at the actual setup for this storm. Okay, this is my favorite satellite picture, the water vapor satellite, and what we have here are two disturbances. We have one disturbance that is off the California coast, and it is rather impressive and certainly is amped up, that is for sure. The European model guidance is correct on that aspect. We have a second disturbance that is moving into the west coast of Canada around British Columbia, and we have a third disturbance that's way up in the Arctic in the North Pole visiting Santa Claus, and that is going to be dropping south. So the question is, how do these disturbances interact? Well, before we get to that point, let's take a look at the North Atlantic. The North Atlantic is clearly showing a developing strong 50-50 upper level low. What 50-50 means is 50 north, 50 west. And when an upper level low sets up in this position, usually it's a very good indication for the potential of a major East Coast snowstorm, because it locks in a high pressure center around the St. Lawrence River Valley and around northern New England, which keeps cold air into the coast and allows a tight thermal gradient along the East Coast, which helps enhance a storm. The problem is that this 50-50 low may be too strong. Some of the model guidance that we're seeing suggests the storm is going to be further out to sea and that the phase really doesn't set up exactly. And the reason why that could happen is that if this upper level low that is spinning off the Canadian Maritimes is too strong, it basically messes up the timing of the entire pattern and forces one piece to move out into the Atlantic and the other two pieces to interact but not really produce an intense coastal storm. On the flip side, if the upper level low is just right and in the right position and at its current strength as it is now, then it would basically block the storm from exiting out into the Atlantic, which means that it just keeps on snowing over New York City and Philadelphia for an extended period of time, which happens to be what the European model guidance is showing. So let's look at the European model guidance. I'm going to point out some of the things that could go right and could go wrong. So here we are on Friday night, Christmas Eve, and notice we have three disturbances. The one disturbance that is moving into the California coast today, that will be over Texas. Disturbance number 2 diving into the upper Midwest, and disturbance number 3, kind of like a dating show here, diving into Ontario. Now, disturbance 2 and 3 have to move south. Why? Because our upper level low to the east of the Canadian Maritimes blocks up the pattern. So it forces disturbances to dive south rather than move east. As a result, the potential for a phase is better. But the problem is that it could also cause suppression of disturbance number 1. And if disturbance number 1 is too far south, then the whole timing of the potential phase is thrown off. Note, though, that all model guidance, and especially the European model guidance, shows a very impressive P&A ridge setup, so obviously we have the potential for a highly amplified flow moving into the southeast, which establishes the potential for a major phase in the first place. So when we move forward another 24 hours, you can see very impressively disturbance 1, disturbance 2 are starting to interact, and disturbance 3 is right on the way, starting to join the party. Is 3 a crowd? Well, it doesn't look like this time. Looks like that based on the European model guidance, the 50-50 low is in the perfect position, blocks up the pattern just enough to slow everything down, and allows disturbance 1, 2, and 3 to interact. Meanwhile, our ridge over the west is in a perfect position, and because our upper level low is not over the west coast is not trying to drive into the west coast, but instead remains around the Aleutian Islands and the western portions of the Gulf of Alaska, we don't see the ridge being pushed to the east. This is a critical time period. If the disturbances do not start to phase in this time period on Christmas night, then this storm isn't happening. Because these disturbances have to phase at this point, or else that ridge starts to get knocked down because the pattern is still moving. The pattern just doesn't lock in, just sit or sit. It's a fluid pattern. It's a fluid nature of the weather pattern. So this timing has to be just right, or else this storm doesn't happen. Very simple. All right. So what we have here again, we have 1, 2, 3 starting to phase. We have a ridge in a perfect position, or a 50-50 low in a perfect position. We have the blocking needed to stop everything and allow this storm to really explode off the east coast. So we move 24 hours into the future, and here we have the result if the phase works out perfectly. A very intense storm off the east coast. We have our block in the North Atlantic, so this storm is going nowhere anytime soon. We have our convergence and confluence over the St. Lawrence River Valley that keeps a high pressure in place, which allows the cold air to lock into the east coast and creates a very impressive thermal gradient along the coastal plain. But notice what I said about the timing of this phase. If this phase is a little bit off by, let's say, 12 hours or even 6 hours, notice that this ridge is starting to move east rather quickly into the northern plains, which should happen because the Pacific is still a fluid pattern. It's not blocked up, so to speak, as far as like a huge ridge and there's nothing coming across the Pacific. There are still disturbances moving through, and because of that, the ridge is going to morph and move just like it did this past week. So if the phasing does not happen specifically on Saturday night, on Christmas night, this storm is not happening because one disturbance is going to be able to exit out into the Atlantic, and the other two will interact, but it won't be as impressive, and it'll be further east. So timing is of the essence. And we go into Monday night, and the upper level low hasn't moved because the upper level low over the North Atlantic blocks up the whole pattern. So that means the storm is going nowhere Sunday night, Monday, and Tuesday morning, if the phase works out perfectly. Notice over the Pacific, we start to redevelop the pattern again, starts to reload and reset up, which is normal for a winter pattern to occur. So as you can see, if this does not set up just right, then this storm is more progressive. Now, if the European model guidance is right, and it's a very good model, so there's a lot of people who think that this is dead on, then what we have in place then is a very dynamic system. Notice at 850 millibars how tight the thermal gradient is over New Jersey, New York City, Long Island, Connecticut. This would produce dynamic, heavy snowfall. I'm not talking about, half an inch an hour. We're looking at the potential for snow bands to set up that would produce 1 to 2 inches per hour. Yes, that impressive. So we would have to really watch this storm and see how it develops, because the potential is there for an impressive snowfall for the northern mid-Atlantic. And if the snowfall wasn't enough, this low pressure system would also produce very strong pressure gradients, which means very strong winds. So not only do we have heavy snow, but the strong winds will create the potential for coastal flooding, wind damage, and significant reduction of visibility. Not good news for the northern mid-Atlantic for Monday and Tuesday morning. So there we have it. Clearly we have a potential for a crippling snowstorm here, but we also have the potential for a complete miss, depending on how this phasing works out. Obviously, I'm not prepared to put out snow maps, unlike other people, but I am prepared to say that this storm needs to be watched, and when I have more data, I will send out alerts as appropriate. I'm meteorologist Stephen DiMartino. Thank you for enjoying NYNJPA weather. Have an excellent day.